In this question, we need to diagonalize this matrix. So that means we will have to rewrite this matrix such that it equals P times D times P inverse. What is D? Matrix D is constructed by the eigenvalues of my original matrix in its diagonal and 0 everywhere else. And P can be constructed by the two eigenvalues of my original matrix. And obviously, P inverse is really just the inverse matrix of P. So that means step number 1, I will have to find all of the eigenvalues of my original matrix. So I need to find lambda. How do I find lambda? Lambda has to satisfy this particular equation, A, my original matrix, times lambda I, the identity matrix, times the eigenvector equals 0 must have non-trivial solution. So by the invertible matrix theorem, if this has non-trivial solution, that means the determinant of A minus lambda I must be 0. So let me fill in the gaps such that this has non-trivial solution, which implies the determinant of A minus lambda I must be 0. Okay, so that will give us what we call the characteristic equation. So I want 6 minus lambda 1 negative 1, 4 minus lambda equals 0. That means we need 6 minus lambda times 4 minus lambda plus 1 equals 0. A little bit of calculation. So for your this, combine the line terms and factor, we will have lambda minus 5 squared equals 0, which implies my eigenvalue equals 5. Well, usually we want 2 eigenvalues, but maybe in this case, my eigenvalue just happen to have the multiplicity of 2. So, which means it corresponds to 2 eigenvectors. See if we could find 2 eigenvectors corresponds to 5. So step number 2. Let's find the eigenvector. How do I find the eigenvector? Let's take A minus lambda I. So in this case, I will have 6 minus 5, 1, negative 1, 4 minus 5. And then apply RIEF. So I need to solve this corresponding equations. And that will give me 1, 1, 0, 0. So that means my x2 is going to be a free variable. and x equals, my eigenvalue equals x1, which equals negative x2, and x2 is my free variable. Let's factor out that x2, and I will end up with, negative 1 and 1. Notice I only have one eigenvector in this case, which is 1, negative 1 and 1, and I actually need two different eigenvectors, two distinctive eigenvectors, so I could find the inverse. So in this case, we will say that my original matrix is not diagonalizable. So we cannot find the D, P, and P inverse. And that is my final answer.